Imagine a world where electricity never runs out, with no pollution and no fossil fuels. Sounds like a dream? Well, this revolution has already begun. Get ready to discover how wind energy is transforming the planet in an astonishing way. Imagine a future where energy is abundant, clean, and renewable, where the winds blow not just as a force of nature but as an engine driving humanity's progress. That future has already begun, and it is being shaped by one of the most ambitious projects in modern engineering: wind farms. The search for sustainable energy sources has led the world to harness the power of the wind more than ever, resulting in massive electricity generation projects, both on land and at sea. But how are these technological giants conceived? How are they planned, implemented, and maintained? Today, you will discover everything about wind energy projects and how they are revolutionizing the way the world consumes electricity. It all starts with a meticulous planning process. Before any turbine is erected, engineers and specialists conduct a series of studies to determine the best location for installing wind turbines. The wind must be strong, constant, and predictable. To achieve this, meteorological towers are installed in strategic locations, collecting data for months or even years. This information is analyzed to determine whether the region has the economic potential to support a wind farm. However, it is not enough just to have wind. Environmental factors, impacts on local communities, and even interference with wildlife must be assessed. Choosing the right location can determine the success or failure of the project. Once the site is selected, the complex implementation process begins. In the case of onshore wind farms, the land is prepared by building access roads, reinforced foundations, and electrical infrastructure to connect the turbines to the power grid. Each wind turbine can weigh hundreds of tons and have towers exceeding 100 meters in height, requiring massive cranes and precise logistics for transportation and assembly. Modern wind turbines are made with carbon fiber or fiberglass blades, designed to maximize efficiency in capturing the wind's kinetic energy and converting it into electricity. The generated energy is then transported via underground cables to substations, where the voltage is adjusted for distribution. However, one of the most impressive innovations in wind energy in recent years has been the expansion of offshore wind farms, installed in the sea. These structures face even greater challenges than onshore farms but also offer significant advantages. Ocean winds are stronger and more consistent, resulting in more efficient energy production. However, building an offshore wind farm is one of the most complex operations in modern engineering. First, geological surveys are conducted to ensure that the seabed can support the massive towers. Then, the foundations are secured, often dozens of meters below the water's surface. Offshore turbines are even larger than those installed on land, with some reaching heights of over 250 meters and blades exceeding 100 meters in length. These maritime giants must withstand intense winds, storms, and corrosion caused by saltwater. Maintaining these wind farms is an entirely separate challenge. Specialized technician teams use boats or even helicopters to access the turbines and carry out inspections and repairs, ensuring that the system operates at maximum efficiency for years to come. Beyond the grandeur of wind farms, there is an economic and environmental factor that makes these projects even more impressive. Wind energy is one of the most promising renewable sources for reducing dependence on fossil fuels. Unlike thermal power plants, which emit large amounts of CO2 into the atmosphere, wind farms generate electricity without pollution, helping combat global warming. Moreover, the creation of new wind farms generates thousands of jobs, from the planning phase to operation and maintenance. Engineering, logistics, assembly, and technology professionals find a thriving and constantly growing market. Another fascinating aspect is the technology behind these turbines. The most modern models feature smart sensors that continuously monitor wind direction and intensity, automatically adjusting the blade angles to extract as much energy as possible. Additionally, artificial intelligence systems are already being incorporated to predict failures and optimize electricity production, reducing costs and increasing efficiency. But are there any disadvantages? Despite its numerous benefits, wind farms also face challenges. One of them is wind variation. Since the wind does not blow at a constant intensity, energy generation can be unstable. That's why countries are investing in hybrid systems, combining wind energy with other sources, such as solar and hydroelectric power, to ensure a continuous supply. Another challenge is social acceptance. In some regions, residents oppose the installation of turbines, considering them visually intrusive or fearing environmental impacts such as noise and interference with local wildlife. For this reason, every new project undergoes extensive environmental assessments and public hearings to ensure sustainable development. The future of wind energy is promising. projects are becoming increasingly ambitious, with mega wind farms being built around the world. Countries like Denmark, Germany, and China are already investing billions of dollars in this technology, while new innovations continue to emerge, such as floating turbines that can be installed in even deeper waters, expanding offshore generation capacity. We are witnessing an energy revolution in real time. The winds that were once just a natural phenomenon now drive the gears of modernity, powering entire cities with clean and renewable energy. If there is one certainty about the future, it is that it will be driven by sustainable solutions. Wind farms, both on land and at sea, are proof that progress can go hand in hand with environmental respect. The question that remains is, how far can we go with this technology? The sky, or rather the winds, is the limit. Beyond the energy revolution that wind farms already represent, the industry continues to reinvent itself, seeking new ways to improve efficiency and reduce costs. One of the most impressive advancements is the development of vertical axis turbines, which can capture wind from any direction without requiring constant adjustments. Although not yet as popular as traditional horizontal axis turbines, these new machines offer advantages in locations where winds are turbulent or irregular, allowing installation in urban areas or mountainous regions where conventional wind turbines would struggle.